All right, welcome to one more installment of Jensen Does Chemistry Stuff. Woo! All right. Now, this time, we're going to do how to balance chemical equations. Yeah. We'll start simple. Now, if you have not yet watched my introduction to balancing chemical equations, I strongly recommend that because it gives you kind of an understanding of why we're doing what we're doing. So please enjoy that video first. Welcome back. All right, so now we need to know that the number and types of atoms we have in the reactants, or the before the chemical reaction side, is equal to the number and types of atoms we have in the products, or the after. And so we're going to use this kind of handy T-chart to help us make sure that everything is correct. So you just start by doing that. Now on this side, you put your R for the reactants. And over here, you put your P for the products. Okay. So step one, what do we have? We have N, nitrogen. So we put the nice N here in the middle. And so now what we're going to do is we're going to count up all the nitrogen on this side of the equation, and then count up all the nitrogen on this side of the equation to see if they're balanced. And our goal is that these numbers are the same. So over here we have 2 nitrogens. Then over here we have 1 nitrogen. So clearly there's going to be a problem, but we'll worry about that in a minute. Next, we have hydrogen. So that's our next element. Over here we have 2 hydrogens. And over here we have 3 hydrogens. Ooh, that's going to be a pickle. All right, well, let's just get started, shall we? First, we're going to start with nitrogen. Now we have 2 here, but we only have 1 here. Now, when we are balancing the chemical equations, we do not touch the subscripts. Okay, remember that. When balancing chemical equations, we do not touch the subscripts. The only thing we can do is put coefficients in the front. That is all we are allowed to do when balancing chemical equations. So we need 2 nitrogens on this side, so we can put a big old number 2 right there. And that gives us 2 nitrogens. So now our nitrogens are happy. We have 2 on this side and 2 on that side. But as we all know, a coefficient applies to everything in that formula. So now we have 2 times 3, we have 6 hydrogens. So we changed it. And that's just a part of balancing equations. You know, you just got to do that sometimes. You got to make more than one change at a time. So now our nitrogens are happy, but our hydrogens are not. We have 6 over here, yet we only have 2 over here. But that's an easy fix. To make there be 6 here, all we have to do is put a 3 in front of the hydrogen. 3 times 2 is 6. Now our nitrogens are happy and our hydrogens are happy. Our equation is balanced. Yay! Woo, woo, woo. All right, do it again. Let's make our little T-chart. This time I'm really going to put it in the middle because I think it helps your brains. Okay, it wasn't in the middle. All right, next time. I get 2 more tries. So, reactants, products. Now, first we have potassium. Then we have chlorine. Then we have oxygen. All right, so let's start counting. And I could check the same, but clearly they're going to be the same on both sides, so like which elements there are. So we have 1 here, 1 potassium there. We have 1 potassium here. Chlorine. We have 1 chlorine here. We have 1 chlorine there. Dang, is this thing already balanced? Oxygen. We have 3 here. Haha, there's the problem. We have 2 here. So we're going to leave chlorine and potassium and chlorine alone, and we're going to go to oxygen. There's about to be some little girls talking. It's my daughter and her friend. Hopefully they will realize I'm recording and go about their business. So we have 3 here and we have 2 there. Now this is a very difficult kind of thing here. It's not easy like It's not easy. Excuse me, girls. Sweetheart, I'm recording right now. All right. Anyway, so what we're gonna do is it's kind of a little trick, because the product that the number that they both are divisible or can divide into, is if you multiply them times each other. 2 times 3 is 6. So 2 will go into 6, and 3 will also go into 6. Another way to think about it is just kind of reversing the 2 and the 3. So I'm going to put a 2 in front of there and a 3 in front of there. So I'm taking this 3 and putting it there, and that 2 and putting it there. In other words, making there 6 oxygens on both sides. So 3 times 2 is 6 oxygens on this side, and 2 times 3 is 6 oxygens on this side. But of course we changed our chlorine, didn't we? Now we have 2 chlorines here, and we have 2 potassiums here. Now that means we need to put a 2 there, so we have 2 potassiums, and we have 2 chlorines. And ta-da! We are balanced. Next, let's do this again. I know this one was a little weird, okay? It was a little weird. But the best thing to do is when you have things that don't work out as well, you just multiply them times each other. So 2 times 3 is 6, make there be 6 oxygens here, make there be 6 oxygens there. All right, let's do this again. And activated the dog. All right. Sodium, chlorine, fluorine. So we have 1 sodium on this side, 1 sodium on that side, 1 chlorine on that side, 2 chlorines on that side, 2 fluorines on this side, 1 fluorine on that side. All right, our sodiums are good, so let's move on to our chlorines. We have 2 over there, and we only have 1 here, so we have to change that. 2 chlorines. But of course, as you see, we also changed it to 2 sodiums. Well, let's fix our sodiums while we're here, right? So now we need 2 here, but now we also changed our fluorines to 2, but that actually turned out to be what we wanted. So now we have balance. All right, so now we're gonna kind of kick it up a notch. This one's a little bit fuzzier. So let's go through. And first we'll make our little chart. I finally got it directly under the arrow almost. Li for lithium. Okay, right now there's little kind of bells going off in my head because this NO3 looks like a familiar thing. And if you pull out your trusty list of polyatomic ions, okay, and here they all are, and focus in, right here you see NO3 is nitrate. It's a polyatomic ion. It's a thing. And so what you want to do here when you notice a polyatomic ion while you're balancing chemical equations is you do a little test. If you can see NO3 just intact as an NO3, you check and see if you find it over here. And there it is, NO3. It is exactly the same, NO3, NO3. If it appears on both sides, if a polyatomic ion, any one of these, appears on both sides of the equation, completely intact, you treat it like a thing, like a unit, okay? It has now become a thing. Instead of a thing, let's call it a turkey. And I'm gonna highlight it. So this whole thing is like a blob. You don't even care what's inside it. It's a turkey, it's a blob, it's a thing. Here we go, it's a thing. And so, oh man, I like disappeared it. All right. Anyway, so since it's the same on both sides, we can just treat it as a unit. I'm gonna fix that. All right, so there we go. We got a turkey on both sides. Now, let's move on. Calcium, calcium, and bromine. So let's start our counting. We have 1 lithium here, and we have 1 lithium there. We have 1 nitrate here, but we have 2 nitrates there. You see this turkey right here? It's in the oven. Okay, so that means 2 entire turkeys that are in the oven. So we have 2 turkeys over here. Calcium, we have 1 calcium here, and we have 1 calcium here. Bromine, we have 2 bromines there, and we have 1 bromine here. All right, let's start to balance. Lithium is good. Now, the turkey, nitrate, we have 1 on this side and 2 on that side, so we need more. Now again, when balancing chemical equations, do not touch the subscripts, all right? We can't stick little 2's down there. It's not allowed, okay? So we have to do coefficients. So we're gonna put a 2 right in front. Now we have 2 turkeys here, 2 nitrates here. But we also now have 2 lithiums. So we got to go back and fix our lithium. So let's put a 2 in front of there. Now we have 2 lithiums, but now we also have 2 bromines. Oh, look at that. It happened again. Just by fixing something, we fixed something else by accident. And so in this equation, what we really learned is that when you have a polyatomic ion, you test it and see, does it appear the same on both sides? If so, you treat it like a thing. I didn't have to count oxygens at all. Okay, I didn't have to count these nitrogens. I didn't have to count those individual. I just counted how many of this whole thing there are. And over here there were 1 and there were 2, so we ended up putting a 2. Now we have 2 of them here and 2 of them there. All right, that's part 1 of balancing chemical equations.